Good morning, friends. We're here for a little photoresistor demo in tinkercad. So I'm gonna begin by pulling out, searching for the photoresistor. We can type it into the search, or I just like to scroll through. I've got one hanging right there, so gonna bring it over. And as I shine light on this thing, it should change its resistance. To measure or to see resistance, I can bring out a multimeter. The multimeter can measure voltage or amperage or resistance. So let's click on resistance for now. I just need to plug my photoresistor into the multimeter. It's the wires are a little bit reversed, so let me just do that and then plug these guys right together. So now when I click on, when I begin to start my simulation, the photoresistor will come alive, and it'll wait for me to adjust the amount of light that it sees in the cloud, of course. So I'm gonna go ahead and let me zoom in a little bit, right, so we get a better picture of really what's happening. I'll press start simulation, and right now it's seeing 180 kiloohms of resistance, and that's because it's sitting in the dark. As I clicked on the photoresistor, I get a slider, and I can now bring on the light. And where I began at a very high resistance, 180,000 ohms, as the light turns on, the resistance goes down. Okay. And in full light, I'm seeing about 506 ohms. So the numbers aren't as important as the direction. Okay. Large light, low resistance. No light, large resistance. Did I say that properly? In the dark, high resistance. In the sunshine, low resistance. Cool. So I'm going to stop that simulation briefly, and I want to move on to the issue that our eyes do not detect kind of low resistance or high resistance. In order to speak to the brain, in order to speak to the Arduino, we need to turn this into a currency of voltage, right? And so there's a beautiful circuit for turning light into a change in voltage, and that requires really just one more component, a resistor. But it also, in order to see a change in voltage, we got to have some voltage hanging around. And in the body, this happens through metabolism, through nutrition. And the Arduino, it happens is because, we got the Arduino plugged in someplace. So I'm pulling out a battery, and he's kind of big. I'm not sure why the batteries are so gigantic in tinkercad. So I'm going to bring out a battery. I'm going to pull this guy off to the side, and I'm going to build now a small circuit that's going to transduce a change in resistance to a change in voltage. And of course, the voltage should be someplace in between 0 and 1.5 volts, right? It's the standard AA battery is 1.5 volts. And our voltmeter might be happier measuring that in thousandths of a volt, which are so-called millivolts. But let's build a circuit and see what we get. And so I'm going to flip this guy around. Orientation is nice to get things working. I'm going to plug the positive into one end of my photoresistor. I'm going to color that guy red for the plus. Let me turn my resistor over so he has a more natural plug into my photoresistor. And notice that the resistor itself that I'm using has already 1,000 ohms of resistance. And that guy is going to get plugged into the other end of the resistor, and I'll just follow the colors of the battery. Black will go to black. And now again, I'm now going to use this as a voltmeter. So let's click on volts. And what voltage am I going to measure? Of course, I already know the voltage of the battery, but the small circuit we just built is a so-called voltage divider. 1.5 volts is going in, right? And then the circuit gets closed back to 0. But there's an amazing intermediate place. And let me go there. You go right here. And intermediates maybe get a special color. I'll use blue for that. This guy's black, and he's going to go right to the black joint, okay? If I can find, there we go. And black is black, right? And so let's just kind of step back and look at this circuit. I really have two resistors in series, but this resistor is light dependent. And so I'm going to begin with 1.5 volts there and pretty much 0 volts there. That's the ground, the reference, the minus. But there'll be an intermediate voltage here. And the intermediate voltage will depend upon light. So this is going to be our trick for transducing light into voltage. Voltage is the currency of thought of the brain and of our artificial brain, the Arduino. Let's see if this really works. Of course, I just have to press start. Hopefully I'm zoomed in far enough. And where am I? I'm in the dark. And in the dark, I see a low voltage, 8.3 millivolts. As I turn up the light, okay, I get a higher voltage, up to 990 millivolts, almost a whole volt, right? We're not getting everything out of this guy because, there's some loss in the circuit. No big deal for us. All we're trying to do in our laser guitar is detect a difference between light and dark. And so for us, that means a high voltage means light, a low voltage means dark. So we just want to detect, when does the voltage go below a certain threshold? That's all we're going to be doing, friends. There's deeper notes in an appendix to our construction manual. And then we'll have a chance to actually turn this into something where when the voltage is low, we play a sound. That'll be the real test. So I'll turn off stop and I'll turn off the recorder. So that's about all for now, friends. Thank you.